Hello everyone. Today the learning topic is linear regression. I hope you have watched the last few videos. In the last videos I had discussed what is supervised learning, what is unsupervised learning, and what is the difference between the two. What are different algorithms which are used in supervised and what are the algorithms which is used in unsupervised. If you have not watched the video, please pause this video, move to the other videos that I've already posted or the total repository. Click that repository, you'll get a good number of videos with all the explanations. It would be easy if you first go through the old videos and then move forward. For all those people who are clear with the concept and have visited all my videos, let's start with this topic. But before that, I would like to say, please like the video, share the video and subscribe to our channel. So let's start today. Everyone must know now what is machine learning. Just to give a brief summary, I would like to say, when you are teaching a machine to learn some pattern and then the machine will give the answer for the next patterns. This is all about machine learning. Now, whenever you are seeing some pattern, there must be relation between two things. That is, what you are giving the input to the computer and the computer will predict something that would be a next variable. See, now there are two different things. There would be pattern between the input and the output. This pattern can be anything. If you think in terms of maths, it may be in the form of an equation. For example, if I say there are certain points which lie in a circle, there would be the equation of a circle where the radius would be constant. So I can say, if someone says that the input is whatever the input may be, the output always lies in a circle of radius 1. So I can have that value. I just gave an example of a circle. Now let's say I have an equation y is equal to 3x plus 4. Again, now y and x are related. And if you see in the previous videos, I have discussed about what is linear equation and why an equation is called as linear. Now, in this case, I can say y and x are linearly dependent. That is, whenever I change the value of x, the value of y changes. Therefore, for example, in this particular equation, if I give some value of x, for example 3, I can have the value of y. So, based on certain input values, you have come up with the equation, learning a machine learning model, giving the algorithm, maybe any type of algorithm. For example, a linear algorithm, a non-linear algorithm, a polynomial algorithm, whatever. And you have come up with the variable that is the output y. Therefore, you have started predicting the value of y. Now let's understand what linear regression is all about and how do we implement these things in Python using the scikit-learn library. First of all, we must understand what is regression. See, regression is the relationship of the x and y. Whenever you are having the data, you are giving the data as an input. I say my data is x or x is the variable which I am giving as an input. Then what the regression will do, it will first try to learn the pattern and then find the relationship between x and y. And now your machine is quite intelligent as you have already applied the model, and with that intelligence, it will predict the value of y. This is regression. Now, if I say my pattern between x and y is in the form of a linear equation, that is y is equal to mx plus c, it becomes a linear regression. Maybe there's some other type of relation, for example, where we use the logistic function that is 1 upon 1 plus e to the power minus x. This is equal to y. In that case, it would be a logistic regression. The next video would be on the logistic regression and I'll give more amount of information how we come to the equation and why this particular equation is used and where should you use. In today's topic, we are focusing on the linear regression. If we go by the definition of linear regression, it's a linear model that will establish a linear relationship between the input variables, that is, independent variable x and a single output variable, that is a dependent variable y. When the input x is a single variable, this model is called a simple linear regression, and when there are multiple input variables x, then the model is called a multiple linear regression. Linear regression is represented as y is equal to a plus bx plus e. I think in the earlier videos we have learned about y is equal to mx plus c. What was m? Just give a pause and think about it. I have already discussed in the earlier videos. M is my slope. Slope means, that is, I think I have already discussed in the calculus part, that was dy by dx. That is delta y divided by delta x. How much your y will be changing if the x changes? That is the slope of a line. And c, that is in this case the a is the intercept. Intercept means if you do not give any input, that is your input is 0, where my line will touch the y-axis. That is, for example, if you do not have any input, still my y will be some variable or some value. That particular value is called the intercept. E is the error term. Now you can see the diagram here. You can see there are certain points and we have tried to give the best fitted linear line here. Every line cannot be the part of the line. Every point, every data point cannot be the part of the line. This is why we will find, like, what have I predicted, whatever my prediction will be will always lie on the line, but all the points will not lie on the line. These two differences will be set as an error. The less the error, better my line is, better my model is, better my prediction is. Now let's understand. In the last slide, we just discussed about dependent and independent variable. You must know what are these. Dependent variables are those which can change as a consequence of the change of the other values. These are called the response variables. And independent variables are those which are called as predictors. These are the input to the system and take the values independently. For example, if I set the equation as y is equal to mx plus c, x will be my input variable, that is my predictor or the independent variable. I am calling this as independent because x can take any random value. But now when I am considering the value of y, it will always depend on the value that we are supplying to the x. That is why here y becomes the dependent variable or the response variable. And my predictor becomes x because with the value of the x only we can predict the value of y. Concept of dependent and independent variables are very important in whatever machine learning algorithms that you use. I've just discussed in terms of the linear regression model, a simple linear regression model where we are having a single variable x and a single output y. Now, a linear model is represented as y is equal to b0 plus b1x plus e. Y is the dependent variable. This is dependent because it is depending on the independent variable x as per this equation. b0 is my y-intercept, b1 is the slope of the line, e is the error term and x is my independent variable. This diagram again shows a simple linear line which follows the equation y is equal to mx plus c. You can very clearly see all the data points will not lie on the line. This is because a model will not learn or not have all the points which is given. There will be some error. It is very impossible to find a model with a zero error. If it is, then it is the exact model or the exact thing what we want. Now, I think we are clear about what the simple linear regression model is. It's a supervised type of model. For example, you need to predict some sales of an ice cream depending, and it depends upon the temperature. For example, I can see with the increase in the temperature, that is when the season is hot, it is a warm season. At that time, the increase in the sales of an ice cream. But in the winter season, we do not have that sale of ice cream. Putting the values into a graph and then finding the scatter plot, we find that it may be a linear relation between the two. You can take some random values of sales of the number of the ice cream that is being sold and the temperature, and then plot a line, plot a scatter graph. And then you can roughly see what is the relation between the two. Then you can find the best fitted line. Now, what would be the error in this case? If you find what you have predicted and what is the actual value, that is the difference between the two, is the error term. You can have the absolute value, that is the exact term that you are using, or the squared values, where we can square it, then average it, and then have the under root, that is the square root of that particular value. So I have already discussed about the error term in the previous lecture, that is the evaluation term. That is what is RMS, that is the root mean square values, and also what is the absolute error. Please go through those videos, because without the error term, the machine learning model is just incomplete. Just creating a model doesn't mean anything if it doesn't predict in a very efficient manner. Now, in this, we'll just learn how to implement the linear regression model using Python. Firstly, we know whenever we are having some data frame, for example, let it be you are getting some CSV, or you are getting some file from the SQL, or you are getting some files from as in the JSON format, or from the MongoDB, you first need to have the connection between the two, import the file in the form of the pandas data frame, and then use the manipulation on it. In this, we are using some inbuilt data set, that is the load Boston. We are using that particular data set. It's a data set which actually gives the house prices and the prediction of it. Firstly, what we do, we import the NumPy, Pandas, Matplotlib, and sklearn. We have already discussed about which library is used for what purpose. NumPy is used for the manipulation purpose, Pandas is used for the data frame purpose, Matplotlib is used for the graphical purpose, and sklearn is the machine learning library where you can have, which is actually the repository of all types of algorithm that we'll be using. Now, sklearn.datasets contain the load Boston. This is a dataset which is an inbuilt dataset which can be found in Python libraries, which has certain features like that of the size of the houses, location of the houses, etc., and you have to predict the price of the house. Now, just to know what are the important things in the data, you can have different type of things printed, like data structure. What would be Boston? We find it as dictionary. Then we print all the keys, then we print the shape, we print the number of features, and we print the description. You can just type the commands in the Jupyter notebook and try to find out what type of data you are using, because without knowing the type of data that you are using, you cannot go ahead, because description of the data is very important before starting any type of manipulation. Now, what I do, I convert my Boston.data into a data frame. After it becomes a data frame, I start using the different commands like .head, .tail, just see what type of data is, how the data frame is looking like. Then I can say what are the columns, what are my targets. For example, I'm just saying that like the fifth one, the Boston.target contains the house prices. I've printed it and I've made it a Boston.target. Boston.target is now saved at boss price. The column name is price, and then I'm again printing boss.head. I'm not showing the types of output here, because at least it would be curious for you people to type these commands by your own and then see what type of output you're able to see. But still, I have given the whole code in my GitHub link. You can just copy paste the code, run it, and see all the different types of output. I have written the description of each and every section in the comments in my code. It would be easy for you to understand from there too. Now, as we are learning the linear regression model, I'll try to fit the linear regression model here and then try to predict the Boston housing prices. I'll use the least square methods as a way to estimate the coefficients. First of all, I am importing the linear regression model from the sklearn.linear_model. Now I know whenever I am giving the input x, it shouldn't contain the output variable. And my output variable y is the price here. So I'll drop the price column from the x variable. I've dropped it. Now I've created a model which is linear regression. The object has been created now. Now there are certain functions which you should know about the linear model. That is lm.fit, that is the model.fit, it fits a linear model. lm.predict, it predicts the y using the linear model with the estimated coefficients. And lm.score, it gives the coefficient of determination, that is the r square value, and this actually will predict how well your model is working. I have now fitted the model. Two variables are given, x and the output. Output is boss price, that is my y variable. And now I have tried to print the intercept, that is, if you remember the equation, y is equal to mx plus c, the equation of c, that was the intercept. This is called the intercept. Then I start printing the coefficients. Firstly, I am printing the length of the coefficients. That means what are the number of coefficients. In this particular model, I have just said b1x plus b0 plus c. But what if I am having number of coefficients? For example, x squared and so on. That is why I first try to have the length of the coefficients, and then I'm printing the number of coefficients and what is the values of the coefficients. I'm converting this into a data frame so that whenever we are printing it, it becomes easy for the end user to see it. This is the type of the output that you can see. Estimated intercept coefficients are 36.45. Estimated number of coefficients are 13. And what are the values of these 13 coefficients? In this, I have not shown how you are drawing the diagram with the help of the matplotlib. That is how your data points are actually, and after the drawing the line, you can visualize that what type of error is there. This full code with this type of error in the diagram has been uploaded in the GitHub. You can see those code. If you have any type of doubt, just write in the comment section. I'll give the answers, or you can mail me my email ID. GitHub link has been shown in the description section and also the last slide. It is the same GitHub link in the other videos are. You can have the other codes there as well. But I just request you to go through the video of the evaluation model, which is very important, because once you are making the model, then comes the evaluation terms. That is, you have to first evaluate how your model is working, whether if even linear regression is wanted in your model or not. For example, if you have such a data set and trying to implement the linear model, and you can see only 1 or 2 data points are rightly predicted and others are having a huge error, this doesn't mean anything. So you have to first understand what type of model should be used, how data is provided to you, and then you have to evaluate it, like dividing the full data into the test and the training data sets. I have not done exactly everything in the code that has been seen in the video, but I have given the full description and the full differentiation between the testing and the test data set, and then evaluating the model. The full code is given in the GitHub. Please have a look, run the code, see the different type of outputs, see the different type of graphs that is being presented, and you'll have a better and a clear explanation and a clear understanding about each and everything. This is my GitHub link. You can have the houseprediction.py. I have made the file there. If you find any error or any type of advancement, any upgradation is needed, please ping me on my email ID or in the comment section. Do like the videos, do share the videos, keep subscribing. That's all for the day. Thank you.